So imagine you're spending 6 straight months, I mean just every single day, documenting every little roadblock, every triumph, every major architectural pivot in this massive coding
Oh,
project.
wow. Yeah, that is a lot of writing.
Right. And you get to journal entry number 198, and you suddenly realize your entire document generation architecture is, well, it's basically being held hostage by a single word, in this case, the word directory.
I mean, that is the classic developer experience right there.
It totally is. And welcome to today's deep dive, everyone. Today we are looking at this highly specific, but honestly incredibly relatable coding journal entry from a developer named Ang.
Yeah, the post was actually published today, July 28, 2026.
Exactly. It's titled Notes on Haskell Programming, Part 198, Dynamic Tips Templates via Pandoc Variables. And our mission for this deep dive is to explore how, just swapping a few static characters for a dynamic variable isn't really just about saving keystrokes.
No, not at all.
Right. It's about fundamentally decoupling your data from your presentation layer. Like it's the key to unlocking total automation. Because sometimes looking at a single line of code is, it's like looking through a microscope. It just reveals the entire philosophy of how a developer solves problems.
It really is a perfect microcosm of system evolution. And
Yeah,
when you were writing a console tool like Ang is doing here in Haskell, your ultimate goal is usually robust automation.
right.
But you can't automate a pipeline if the final output relies on, someone manually tweaking a layout file every single time the year changes, or if a publisher updates their name.
Yeah, that just breaks the whole chain.
Exactly. That transition from a rigid state to a parameter-driven state is, well, it's a hurdle every developer inevitably hits at some point.
And to really grasp the mechanics of what Ang is doing, we kind of have to look at the context here. Like I mentioned, this isn't some weekend hackathon project.
Definitely not.
This is part 198 of a coding journal. I mean, Ang has been writing about programming in Haskell for 6 months. And for you listening, if you aren't familiar, Haskell is a purely functional programming language.
It is notoriously strict.
Very strict. It requires this very disciplined, deliberate approach to how data flows through an application. It doesn't really let you get away with sloppy architecture.
That context is so vital, honestly, because when a developer chooses Haskell for a console tool, they're usually prioritizing type safety. They want predictable functions, and they want to avoid side effects.
Right. They want a system that's basically bulletproof once it compiles.
Precisely. And to maintain that level of rigor for 198 journal entries, that indicates an incredibly methodical mind. You can tell Ang is dissecting literally every architectural choice along the way.
Which is exactly what makes the friction Ang encounters here so interesting to read about, because despite tweaking this default, what's called a Typst template for quite some time, Ang admits in the post to not actually having written about it yet.
Which is funny, considering it's part 198.
I know. And just a quick note for you listening. If you work with document generation, Typst is this modern, incredibly fast typesetting system. It's often used as an alternative to LaTeX.
It's very popular right now.
Yeah, it's great. But Ang's default template had this critical flaw. Crucial metadata was permanently baked into the design file itself.
The hard coding trap.
Yes, the hard coding trap. The publisher's name, the year of publishing, and the table of content title were all just hard coded right into the file. It's kind of like, okay, imagine printing a batch of beautiful, really expensive party invitations,
Okay, I like this.
but you print party at 8 p.m. directly onto the card in this fancy gold foil. If the time changes to 9 p.m., you can't just cross it out. You have to throw the whole batch away.
You're starting completely from scratch.
Exactly. That is hard coding. So let me ask you, why do developers fall into this hard coding trap in the first place if it's really so limiting?
Well, what's fascinating here is that hard coding during the scaffolding phase of a project is actually standard practice.
Really? Like you
Yeah.
do it on purpose?
Oh, yeah. Because you want to see if the layout engine actually renders the margins correctly or, if your font choices even look good. The path of least resistance is to just type a dummy publisher name and the current year directly into the .tip file and run the compiler.
Okay, that makes sense. You just need placeholder text to see the design.
Right. It's a shortcut. The problem is that the shortcut eventually becomes a massive roadblock.
Because relying on that in production is, I guess it's like welding your car's tires to the axles?
That is a very vivid image.
Right, sure. It guarantees the wheels will never fall off while you're testing the engine in the garage. But The second the tread wears out, you have to throw away the entire car. Or,
Mhm.
well, in Aang's case, you risk breaking your entire layout file just to update a copyright year.
Exactly. You've permanently locked the data and the design together. And that fragility completely defeats the purpose of writing a robust Haskell console tool in the first place.
Because the whole point of the tool is automation.
Yes. If the data is welded to the presentation file, your automated command line interface is paralyzed. It can't orchestrate document creation if it constantly requires a human to manually open a text editor and do a find and replace on strings in the layout template.
That completely defeats the point of having a machine do the work.
Yeah.
Which brings us to Aang's explicit motivation for today's refactor.
Yeah, the turning point.
Right. Aang writes in the journal, and I'll just quote this directly, "Before we can add customization through new arguments to the console tool, we need to move these hard-coded values from the template file to the source code."
That single sentence represents a massive architectural pivot.
It really does. But I do have to play devil's advocate here for a second.
Go for it.
Because moving this data to, quote, the source code sounds really elegant on the surface, but isn't Aang essentially just moving the technical debt from one file to another?
How do you mean?
Well, if I have to open my Haskell source code to change the publisher name instead of opening my Typst template, I am still technically just manually changing text in a file, right? So where is the actual automation or time saving in that?
Okay, that is a fantastic question. And it's the exact trap a lot of developers fall into when they try to decouple systems. But there is a crucial distinction in what moving it to the source code actually means for a console tool.
Okay, break that down for me.
So Aang isn't just hard-coding the publisher name into a Haskell string instead of a Typst string. By pulling the responsibility of that data out of the template and into the application, the source code can now expose those values as parameters.
Oh, I see. So exposing them as like command line arguments.
Precisely. The source code starts acting as the traffic cop. Instead of the data living anywhere permanently, it just flows in at runtime.
Got it. So the user interacts with the tool, not the code.
Exactly. A user can type a command like -- publisher and then O'Reilly or -- year 2026 directly into their terminal.
And then the Haskell code just catches that.
Yes. The Haskell source code captures those arguments, validates them, and passes them down the pipeline. If the template file still had those values hard-coded, the Haskell application would have no way to inject that new user-provided data.
Because the template would just stubbornly render whatever was welded into it, right? It would completely ignore the console tool.
It would. By moving the data handling to the source code, you establish this true separation of concerns. The .tip file becomes a pure presentation layer. It's essentially an empty container that only dictates styling, margins, and layout.
And the Haskell code becomes the logic layer.
Right. Fetching and formatting the data, completely agnostic of what the final document actually looks like.
Okay, that makes so much sense. But knowing you need a dynamic template is only really half the battle, right?
Oh, for sure. Implementation is the hard part.
Yeah, because if your console tool, the application that's actually gathering all these arguments, if it doesn't have a reliable mechanism to inject that new data into the presentation layer, you're just back to square one.
You are. You have to build a reliable bridge between the data and the design.
And this is where we get into the actual code diff Aang shares. The bridge Aang utilizes here is Pandoc.
Yes, Pandoc is incredibly powerful for this kind of thing.
It really is. It functions as the middleware between the Haskell logic and the Typst compiler. Let's look at the specific syntax Aang shares in the entry because this is where it gets really interesting.
Let's do it.
We can see exactly how this transition is handled by looking at the diff for the table of contents title. In the old hard-coded version that's being removed, the line of code looks like this. It's a minus sign, hash outline, and then in parentheses, title colon, bracket, some Chinese characters, close bracket, comma, indent colon, 1
Right, and just for context, those Chinese characters inside the brackets, they're pronounced mulu, they translate directly to table of contents or directory.
Exactly. And no matter what arguments you pass to the console tool or what language you wanted the final document to be in, the layout was going to forcefully print those specific characters.
It was unavoidable.
But now let's look at the new code Aang adds to replace it. It's a plus sign, hash outline, parentheses, title colon, bracket, and here's the change. $, TOC title, $. And then the rest is the same. Close bracket, comma, indent colon 1
Notice how the structural design logic remains completely untouched.
Yeah, the outline function, the indent parameter, it's all intact.
Right. Only the specific string value was extracted.
So by stripping out the raw text and wrapping that talk title variable in those dollar signs, Ang is essentially bypassing Typst's native string rendering, right? Like explicitly flagging this spot for Pandoc's templating engine to target.
You've hit on the exact mechanism of the abstraction there. The Typst file itself is effectively dumb.
Dumb in a good way.
Exactly, in a system design way. It doesn't know how to query a database or read command line arguments. But by wrapping that variable in dollar signs, Ang creates a placeholder that Pandoc natively recognizes during its abstract syntax tree transformation phase.
Okay, abstract syntax tree or AST. For anyone who isn't deep into compiler theory, Pandoc basically reads the document, sees those dollar signs, and says, hold on, don't print this literally. This is a metadata request.
That's a great way to put it. Pandoc acts as the universal translator in this pipeline.
So walk me through the exact order of operations then. When the user hits enter in the terminal, what happens?
So when the user fires off the Haskell console tool, the tool gathers the data. Let's say it's a custom table of contents title in French this time.
Okay, so the Haskell tool grabs the French title.
Right. It packages it into a metadata block. Then Pandoc intercepts the process. It reads that metadata block, scans the Typst template for any variables wrapped in dollar signs like our talk title, and it dynamically injects the correct data into those placeholders.
And all of this happens before the Typst compiler ever even touches the file.
Exactly. By the time Typst sees it, the French title is already perfectly in place.
That is an incredibly powerful handoff. And when you look at the broader implications of Ang's micro lesson here in part 198, I mean, this isn't just about translating a table of contents.
No, the scale of this is huge once it's implemented.
Right. Once you establish this bridge, once your console tool knows how to pipe data through Pandoc into a static layout, you have basically unlocked infinite scalability.
You've created a system capable of continuous delivery. I mean, you could theoretically write a script that calls Ang's console tool 50 times in a row.
Oh, wow. Yeah.
And you could pass in 50 different publisher names, 50 different publication years, 50 different translated titles.
And you generate 50 perfectly formatted, entirely unique PDF documents in a matter of seconds.
Without ever once opening the template file.
That is the dream. The design just remains pristine, totally protected from human error, while the output becomes endlessly customizable.
It's the ultimate realization of separating data from design. You build the tool once, you test the design once, and then you just let the data drive the output forever.
It is brilliant in its brevity. I mean, changing one static string into a dynamic variable fundamentally evolves the entire architecture of the application. It shifts the burden of work from the human right back to the machine.
Which is exactly why we write software in the first place.
Exactly. We want the machines to do the tedious parts.
It also really speaks to the value of meticulous documentation, like
Ooh.
Ang's 198 journal entries.
I was just thinking that.
Yeah, because a developer could so easily gloss over this single syntax change in a git commit message.
Yeah.
Just, fixed hard-coded title and move on.
Right, just a one-liner that nobody ever thinks about again.
But by stopping to document the why behind the change, the need to support console tool arguments, Ang highlights this universal principle of system design. And it applies far beyond just Haskell or Typst.
It really does. Which honestly leaves a pretty compelling question for you listening to consider as you review your own digital infrastructure today. You might not be writing a purely functional Haskell application to compile typesetting documents. I mean, most people aren't. But the philosophy of decoupling your data from your presentation, that applies universally.
Oh, completely. Whether you are maintaining a complex Notion workspace, or maybe you're writing automation scripts for your operating system.
Or just organizing boilerplate emails for your clients.
Right. The friction of hard coding is literally everywhere in our digital lives.
It is. So if Ang can parameterize a simple table of contents to completely automate an entire document generation pipeline, what hard-coded routines in your daily digital workflow are secretly functioning as welded tires?
I love that analogy.
Thanks. But really, think about it. What rigid systems or templates are you manually updating every week that could be set free by just simply letting the data speak for itself? Take a look under the hood of your own processes and see where a few strategic variables might just change the way your entire machine operates.
It's a great thought experiment for any workflow.
Absolutely. Thanks for joining us for this deep dive, and we'll catch you next time.